Okay, so as a reminder,
Hi, Richard.
UNO dual enrollment is due tomorrow.
Hooray.
Okay, if you have not written this down, write it down. If you have to use the power reducing formula, you need that identity to help you go back into X's. Okay, today I'm not teaching you anything new. I'm just teaching you what happens if we don't have verbatim what we've been doing the past, well, over the weekend, right? What if you don't see the x squared minus a squared, or a squared minus x squared, or x squared plus a squared? Okay, I see the square root, ooh, that's exciting, okay? You should always look for what first before we try any other method?
Use substitution.
We should always look for use substitution. Unfortunately, that's not a good idea here because these two don't have the relationship of composition to derivative, right? If that were an x on top, we still wouldn't be good to go, right? Because it is 4x minus x squared. We don't have a good relationship at all, okay? So, what are we gonna have to do?
Find the square.
Square.
There's a negative x
I just
squared.
heard someone else say it.
Okay. So let's come right here. Let's change this to negative x squared plus 4x. Can we complete the square with a leading coefficient other than 1?
No.
Okay.
Would negative one is like the same.
What's the like formula?
It is not. Excuse me, what?
What's the like formula again? Like a half of b something squared or something like that?
Yeah, you take b over 2 and you square it. So, Caleb, what goes here?
4.
Okay. B over 2 squared is 4. Now, since we added 4, we need to subtract 4.
Don't you add 4 then?
Ah, we're really subtracting 4 times negative 1. Right? So this becomes a positive 4. So we have 4 minus the quantity of x minus 2 squared. So our integral is the integral of x squared over the square root of 4 minus x minus 2 squared dx. Whew.
Thank you.
Now, our process doesn't change. This is still a great candidate for trig substitution, using which substitution? Sine, cosine, tangent, secant, sine. We don't do a cosine substitution, right?
No.
That's not.
No,
Okay.
don't do that.
Now,
Wait, is there?
am I gonna let x equal something?
U equals x minus
X
2.
minus.
Ah, x minus 2 equals
2 sine theta.
2 sine theta. And so dx equals 2 cosine of theta d theta. Okay. Let's also draw our triangle, and to really fill up this space right here that Benjamin was bothered by earlier. Okay, so our sine ratio would be x minus 2 over 2. Right? And so this side would be the square root of hypotenuse squared minus leg squared. Is what we see in our integral. All right, now for the fun part.
Oh, yeah, I'm gonna have a blast.
So we have the integral of, let's take care of our denominator first. 4 minus 4 sine squared theta. That's great, right? Okay. X squared. X would be 2 sine of theta plus 2. Because we would have to take this 2 and add it over to solve for x. Benjamin?
I think I'm good, yes.
Okay.
Yeah.
And then dx is 2 cosine of theta d theta. Okay.
So this one will be like one on the quiz. Are we gonna get straightforward questions, or are we gonna have to do this?
Potentially both. But I'm not gonna ask you 10 questions on your quiz. You know what I mean?
Maybe 3.
So how many questions is it gonna be, like, generally speaking here?
Well, remember we had our trig substitution, and we have this. And I don't remember,
Isn't
but,
this trig substitution though?
our trig integrals, sorry.
Triggy with.
Like our integrals that involved like sine and cosine together, and then we did u substitution with them.
I kind of remember that a little bit.
Okay, let's finish this problem and then we can worry about the quiz later. All right, so right here, what can happen? We can factor out a 4, right?
Yeah. Square root. So it's 2 cosine.
So can we all agree that this reduces to 2 cosine theta? Okay. Do you think we should just leave this binomial squared?
Yes.
You would like to?
4 sine
Yeah.
squared plus
No.
4, and then it also turns into 2 cosine theta.
How about 4 sine squared plus 4 sine plus 4?
Oh, right, cause it's that
That's not plus
stupid
8.
thing.
Is it not plus 8?
Oh, it would be 8. Gotta double it, I'm sorry.
Huh, I'm not the only one who was wrong this time.
You really wanna push that?
Just a little bit.
We can cancel those out. We're just good to go, we're gonna take our antiderivatives,
Why not?
because we can't take the antiderivative of
Sine
Sine
squared.
squared.
sine squared. So sine squared is going to have to become 1/2 minus 1/2
Cosine.
cosine of 2 theta plus 8 sine theta. Okay, we're just making sure. Okay. Four times 1/2 plus 4.
6. No, 6.
4 times negative 1/2 cosine of 2 theta. Okay, now we can take the antiderivative.
No.
Hi.
I think so.
What's the antiderivative antiderivative of 6?
I got it.
Minus 2 cosine of 2 theta.
That minus sine two
Using your brain, think.
And then this?
theta. -4 cosine
Why does it stay as 8?
Because
No
there
change.
wasn't
Oh, there was no
two
2
in the middle, okay.
Yeah. But before we can go back to our triangle, we need to have an angle of theta. So the sine of 2 theta needs to become 2 sine theta cosine theta. And now, since we started with an integral in terms of x, we need to go back to an answer that has an x in it. So here we go. 6 theta. 6 inverse sine of x minus 2 over 2. If we solve for theta, right? X minus 2 over 2 would equal the sine of theta. Do you agree?
Yeah.
So if we solve for sine, or theta, excuse me, inverse sine of x minus 2 over 2. Okay? Minus 2 sine theta. So that's opposite over hypotenuse. Cosine theta. Adjacent over hypotenuse. And then minus 8 cosine theta. Adjacent over hypotenuse. Okay. Now, some of you are going to be like, oh, I really want to make that look nicer. Yeah, you can cross out those 2's and simplify. You can simplify here to 4. I have no problem with that. Okay? I have no problem at all. Did I escape that picture before
Yeah.
we took it? Okay. That was a lot to process. Ask me a question.
Why do this?
Yeah.
Huh?
You have to do this.
You're supposed to be my students who are like, yay. I love learning math.
Okay, but like that's a lot.
I know.
That's one problem.
That is one problem.
Is this the one I was supposed to build the whole board?
Yeah.
Wait, so.
But there's that top right corner.
Would you like that challenge for me next time to
Please
fill up the
stop
entire-
talking, Benjamin.
I
No, Benjamin.
Knowing how much
I
work
really
that
do
is,
kinda wanna see
how
it
many of
go.
those are we gonna have to do on the quiz?
1.
Wait, the quiz is only one question?
You said how many of these?
Oh, it's one of those, and then there's, okay. I'd be so happy.
I'm ready.
All right.
Disgustingly small.
Now, what we need to talk about now
I took out.
is the situation if we were to have limits of integration.
No way.
Question.
What's the point of doing integrals if we don't ever use them to find anything?
They look pretty.
We can plug them into.
That,
a
that looks
looks
pretty to you?
Okay? On Friday, when I'm gone for UNO math competition, your day is going to be doing an application worksheet. Like here is a rotation problem that you have to set up and then use one of our integration strategies to actually solve it. Okay?
Wait, when is this happening?
Friday.
Am I gonna be like 3 kids?
I'm sorry, I'm gonna be on Friday.
We're gonna learn that
You're
with
still gonna have
this,
to do it.
just before the quiz.
Well, yeah.
We're not ready.
Okay,
Wait,
last
are we-
example.
Question.
Answer.
Are we learning any more new things other than the sine of 2 theta equal the 2 sine theta cosine theta
In terms of
Yeah, I'll
today's
tell you after.
identities?
today? No? Okay. I just need to know so I can organize my notes.
Okay. How is it?
Why would you organize your notes? I just kind of write things down as they happen.
I figure.
Okay. would like to give you 60 seconds to work together with the other 2 or 3 people at your collection of desks
If you don't get it by the time.
and set up the substitution and draw your triangle. Just set up the substitution and draw your triangle. Do nothing else.
What will happen if we try and do the whole thing?
X was a 12. We have an X squared plus.
Because you might do something you don't need to do.
But it is a lot of.
This is obviously not X, there would be, there would not be an X.
You can go with X.
Don't write it like that.
At least I would know.
Maybe
Maybe
not.
nine minus
I
nine.
would have written.
So the opposite is U, which is X.
Alright, is the graphic here.
It makes sense.
Oh,
There's
okay.
so few, it's X squared
Should be
plus
negative
9,
6X.
that's A squared plus E squared, 3.
So how are you saying?
Okay, so
A
eight.
tangent beta.
So 3 tangent theta.
So X equals 3 beta.
Yeah, because you're going to work.
Well, are we gonna end up solving it too?
I don't know.
Which means X equals
I'm
3
gonna keep
tangent
going.
theta.
Can't mess up on the small mistakes. We know we're gonna mess up on the actual.
So the tangent is TOA
Huh?
opposite.
You know, you got
I
that.
chose the triangle.
Yeah,
Opposite
and then
over
you just use those X and the 3.
Yeah.
What? 3?
Yeah, A squared plus
Over
U.
1.
A squared plus
No,
U squared.
right.
And U equals A tangent theta.
dx is so tangent is what? 3 so square root of
Substitute
3.
in.
Yeah.
I think we'll just keep solving it. I just feel like that was a little bit easier. Thanks, guys. And then just
Now, the
plug
triangle
in.
or what X is trying to
Where it always have.
What do we need to know? Oh.
Okay, when we solve it out and then you just plug in the numbers at the end. Just go right plus. So it's 3, or, what's 3? Or 27. Which is 27 cubed theta over.
Okay. Marina, what's our substitution? Which means dx is, okay, so your triangle would be, let's see, x over 3 for our tangent ratio. So we have the square root of x squared plus 9. Okay, now we're going to go ahead and we are going to make this the integral of x cubed. So 3 tangent theta cubed. We have the square root of, so can I just make that that? And then 9 tangent squared theta plus 9 times 3 secant squared theta d theta. Now, hopefully you're not working ahead of me.
Is the square, for the triangle, is the square root always going to be like the same thing as that other square root?
Okay. Now, how many of you, when we get to the end of the problem, feel like, oh, I have one more step because I have to change it back to x's? Like, does that, okay.
That's me.
Remember that when we do substitution, like when you did u substitution, you had the option of changing your limits of integration to be in terms of u to skip that step at the end. You have that same option here, all right? If x equals 3 tangent theta, well, this x value is 0.
Oh.
What would it make theta equal to?
The arctangent of 0.
Which is?
I'm supposed to know that?
What?
What angle would make our tangent ratio 0? And then we would have, if x equals 3 tangent theta, our other limit of integration is 3. So we have 1 equals tangent theta.
This one is tangent. Would that be like pi over 4 question?
That would be like pi over 4.
I was thinking 45 degrees, so.
Okay, I guess
It
that,
is though.
that works too.
I was just gonna leave it in terms of the anti-group, the like inverse.
You can do that.
Like, would we have a calculator for this?
No.
Could we just, no? Yeah.
So you'd have to change it to x and then plug all this in. That doesn't.
So now we're saving ourselves a step. Okay, so we have 81 tangent cubed theta secant squared theta all over. Can we all agree that this becomes 3 secant theta?
Yes. Yeah, we
Chris.
did the same thing.
Will the thing under the denominator more or less usually equal what our dx is?
Not always, no. No. Sorry.
Okay.
Okay, so now we can simplify this a little bit, right? 0 to pi over 4 of 27 tangent cubed secant.
Now what is the question? I always get down to like these parts and then I'm like,
And that's why we did Thursday's lesson. The one that you're not remembering.
I don't know.
We have tangents and secants together in an antiderivative.
Oh, this where you have to like change the, split it to like tangent squared times tangent.
What would our u substitution be? Okay, like if u equals secant theta, then du equals secant theta tangent theta. D theta. So yes, we would have to change this to be 27 tangent theta times
Times tangent theta secant theta. No, tangent squared theta. Or no, yeah.
Isn't that that?
Yes.
I remember this because I did both of these yesterday.
Oh.
Now what?
Yeah.
Now we have the integral of 27 times u squared minus 1 times u du.
What's with the bridge 27?
Whoa.
Oh, it's not the main way together.
Do we agree?
Okay, you can do 27.
Oh, no. We don't have this u. Sorry. We don't have that u.
How do we not have it?
Because
Oh,
du
got it, okay.
needs to equal secant theta tangent theta. Here is secant theta tangent theta.
And then the other part's the u squared.
Okay, so we have 27 times 1/3 u cubed minus u. Evaluated from 0 to pi over 4.
Wait, how do you have secant cubed?
Because the antiderivative of u squared is 1/3 u cubed.
Oh, and then you plug, okay.
Yep. Okay. Now we get to evaluate. So we have 27 times, what is the secant of pi over 4?
It's 1 over cosine, so it's 2 over radical 2.
So radical 2. And what's the secant of 0?
One.
One.
Would we just leave it like that?
No.
No. Dang it.
Wait, so why is it not 2 over rack 2?
It is.
So why is it only rack 2? Oh, you mean, okay.
Tangent theta is supposed to be 1 over radical 2. We like make it rational and multiplying the top and bottom by radical.
You mean cosine and
So-
sine? Yeah.
Yeah, that's what I meant. So
Okay.
cosine is.
So this would be 27 times 2/3 radical 2 minus radical 2 minus 27 times negative 2/3. So we end up with 18 minus 19 radical 2.
Minus.
Wait,
Got 9 radical 2.
Whoa. Wait, how'd you get 2/3?
Radical 2 times radical 2 is 2.
Uh-huh.
So radical 2 squared gave me 2 with 1 left over.
Okay,
Oh,
got it.
couldn't you also factor out the 27s? Maybe. Or just-
Yeah, so what I did, 2/3 radical 2 minus radical 2 is negative 1/3 radical 2, so this is a 9. Sorry, I don't know why I wrote 19. Radical 2 times radical 2 times radical 2. Okay. Deep breath. Did I fill up more of the board for you, Benjamin?
That's like all of it.
There's like,
Well, I mean, there's
you
space.
can't write it for me.
Like-
There's like that space at the bottom.
Yeah, there's
That's just
12,
all the
like,
way across.
12 inches of just like nothing.
Richard A. McLean.
How come,
You
Yeah.
need more exclamation
how come
points, but you
everything's
could get there
capitalized except for
eventually.
the
And then there's just that top middle
That
area
is a
that's just
capital.
all-
That is a capital I. There's no dot.
It's just a tall I.
Isn't there usually like the line on top or is on the line on bottom?
It's just besides the font that you write.